I just want you to know I see through the math.
I see you.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 327, a Ploopy knob, a Rube-Goldberg book scanner, and hard drives and power grids oscillating out of control. Happy 4th of July, if you're listening to this on Friday. Do you have 4th of July plans?
Just avoid the artillery.
That sounds good.
Yeah, a couple years ago I got hit in the chest with some shrapnel from a nearby amateur-launched mortar.
Oh, no way.
Yeah, it hit me right square in the chest and in the jaw and just took me by surprise. It was pitch black, couldn't see a thing, and all of a sudden I'm just getting hit with plaster. So,
Ow.
Yeah, it hurt. I'm not gonna lie.
Damage or hospital trip?
No, it just hurt.
Okay.
Took me by surprise.
Yeah, man.
Shouted to the guys across the street and I said, hey, ow.
Oh my God. That's pretty funny. Man, I don't have any dangerous 4th of July stories, which is weird because I grew up in Nashville, Tennessee, where, well, I guess fireworks aren't legal in Nashville, but it's not very hard to leave the city limits, buy fireworks, and drive back home. But,
yeah, it's not legal here either, but no. Yeah, you ain't stopping that bus.
Well, it sounds like these are homemade anyway. It's, I don't say any names. The alcohol, tobacco, and firearms and explosives may be listening. How come they get all the good stuff in one agency? So happy 4th of July for those of you out there celebrating. In Hackaday news, the SuperCon call for proposals has been extended 1 week. So yesterday was the official deadline, but we will give you until July 10th, the 10th of July, to get your proposal in. I'll throw the link in the show notes here. You can head on over, fill in the form with the abstract, your title, your name, etc., and whether you'd like to do a 20-minute talk or a 40-minute talk. We'll wait until the 10th for the last few stragglers to trickle in, and then we'll get to deciding shortly. If you're wondering why we always extend it a week, the answer is because people regret it when they miss the deadline, and then they turn around and they're like, I should really have submitted a project. Who was it? It was Zach Frieden last year, gave a talk on his Graver, which was a circuit board cutting scribe machine. And he saw the end of the deadline come up and he was like, oh man, I really should have submitted the talk. And then we extended it. And then he's like, okay, I'm submitting my talk. And he's like, the machine's not done yet. In fact, he'd done a bunch of research on it, but he'd never gotten it working. And he's like, screw it, I'm submitting my talk anyway. And I love that because A, it gives you an excuse to work really hard on this project during your spare time for the next 3 months. And B, that's the hacker spirit. So even if your project isn't 100% done yet and you want to get it in, this is your time window. This is the time window for the procrastinators and the people who need to kick themselves in the butt.
Well begun is halfway done, something like that.
I'll take it. I like it. The road to hell is paved with good intention. Oh no, that's something else.
Perfect is the enemy of done. There you go. That's the one you want.
And also the 1 Hertz challenge is a week old now. This is a DigiKey sponsored challenge, $150 gift certificates, 3 of them in the offering for the coolest, craziest, most intricate, least intricate, most brutal projects that do anything once a second. And this contest idea was actually submitted by the one, the only Dan Maloney.
Yay. Yeah, it just sort of popped into my head one day. Like, hey, wow, 1 per second anything. How about that?
I think it's really fun. And we have, kind of subcategories for highest precision, but then also for, jankiest mechanisms. Of course, one for using a 555 timer.
Of course. My hope was that there would be cool mechanical versions of 1 second oscillators.
Yeah.
Some sort, springs or pendulums or whatever. So I'm hoping to see those too. I want to see the electronic stuff too, of course. That's going to be fun. But something mechanical, something oddball would really be fun.
We have a clockwork honorable mention category for exactly that.
Oh,
for the
cool. All right.
Crazy mechanical inventions. As always, we have a few entries on the day that the contest is submitted because, people have something like this already sitting around or even an I/O project already written up for it. So that's always fun. One of our writers wrote one up before he even realized the contest was on. That's coming out soon. Anyway, get yours in if you have something that does something, wild, wacky, or otherwise, once a second. Make a Hackaday.io project for it, and there are 3 $150 DigiKey gift certificates out there for the winning. Thanks, DigiKey, as always, for sponsoring these. And I think that's for business. Let's do a What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
Alrighty. Do-do.
I should apologize in advance. This is one of those where you either get it or you don't, I think. Like sometimes you can guess it. It's got like reverb or, funny static or, it's obviously some signal processing thing and you can, dig around the right radio signal encodings. This one's not like that. So good luck. Good luck,
one
Dan.
of those. All right.
It's my bad if you don't get it.
A fellow scientist. This all looks nominal. I hope no one expects me to start up the generator. Smithers went down there and never came back. That's odd. Don't shoot! I'm with the science team!
Wow. I mean...
Yes, no?
No. It sounds like Billy West's voice.
Ooh.
What he's talking about and what forum it's within. I mean, it sounds like a video game, soundtrack of some sort. But, yeah, right at the end, it sounded like Billy West. So I'm going to just leave it there.
I like that. I don't know who Billy West is, and let me see if
Billy
it
West
was
does
him.
Ren and Stimpy and Zoidberg on Futurama, a bunch of other. He's very prolific voice actor.
Right on. I do not know if it was him or not. It doesn't show up in his credits. So
Okay.
I guess it's not him, but that's pretty cool. Again, this is one of those where if you've played this game, good guess, Dan, you will know what this is. So everybody out there, head on over to hackaday.com/podcast, scroll on down to What's That Sound, and fill in your best guess. Leave your handle, your email, and we will pick among the correct answers next week. We'll see who the gamers are out there. All right, then. Well, let's head on off to the hacks. I wanted to start off with open source knob packed with precision. And this is another desktop peripheral in the Ploopy series. I love saying that. This is the Ploopy knob. And Colin has been making a bunch of ultra fancy, almost entirely 3D printed, entirely open source desktop peripherals from a mouse. Actually, his trackball is really great looking. And this is now kind of a scroll wheel / scrubber wheel. If you need to do a lot of audio editing, for instance, you may want one of these, or scrolling through long PDFs, or et cetera, et cetera. It's really fun to have a separate peripheral that, just does jogging. And this is one. It's completely open source. The kind of outstanding parts of the design here is that it uses a really big bearing inside the 3D printed case, so it rotates really smoothly. And it uses a magnetic encoder. So it's got no drag on it except what comes from the bearing. So that's kind of cool. And it's got 12-bit position encoding. So it's accurate down to basically 0.01 degrees. Certainly overkill for scrolling. Runs the QMK firmware, which means you can customize it fairly easily. And if you've played around with QMK for any sort of keyboard designs, you probably know it already. And that's about all there is to say about the device itself. What was fun in this one was what happened in the comments. And I think some people just couldn't find the source files and were like, hey, this isn't open source. I only see the binary to flash to the PyPico. They just didn't. It's not entirely obvious where the source code is. His fork of the QMK repository, and pull out the knob branch and it's got his customized code in there. So indeed, fully open source. The other bone of contention was that maybe the 3D design files weren't all open source, and they're in step. And this is where it kind of gets interesting. And this is kind of what I wanted to rant about here, was that what is even an open source CAD file? We know what it is with source code. And if you're doing your designs in OpenSCAD, right, that's all just source code. So we know what that means. but like people don't consider a PDF of a circuit diagram to be open source because it's hard to manipulate and change, right? It's well documented, but it's not easily changeable in the same way that open source software is. You can't just get in there and edit it, right? What do you do for CAD files? And I don't think there's a good answer to this. I mean, STEP is pretty darn good in that it encodes the geometries in pretty reasonable ways. It's not like STL where it just turns it into a whole bunch of random triangles. STEP still says, okay, here's a cube that's this size, and here's a sphere that's this size, and here's an arc here, and stuff like that. It's easily manipulable as well, and kind of half parametric, but not fully parametric. And I think that's what grinds a lot of people's gears here, is that when you have a fully parametric CAD file, it makes the design intent much more clear and much more obvious. You say, here are these two holes and they're separated from each other by 50 millimeters. And that makes it super easy when you want to change it to be like, okay, I need that to be 49 millimeters. You just type in 49, hit enter, and it recalculates the thing. And that's the way all the parametric designs work. But to the best of my knowledge, there is no open parametric design format. And so when you're stuck with that, maybe something that's kind of an easily manipulable geometry file like STEP is the best we can do. But it isn't quite the source anymore either. Interesting discussion going on in the comments. Sometimes it gets a little bit heated, in my opinion, and people should just chill the heck out as Janu says, hey, this gift horse has imperfect teeth. But honestly, I think it's a neat question if people can remain civil about it, because, I don't think we have the perfect open source 3D printer / CAD / 3D modeling file format.
No, and the few packages that I've used, it's been mostly Fusion, but the value that I found, because I'm kind of an amateur, so being able to go back in the timeline at the bottom has been super valuable. Okay, I really shouldn't have done that 4 steps ago, dink, 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 go back, fix it, and then continue on. And not being able to capture that, although I guess maybe that's more of a prototyping tool than distribution level sort of thing. But still, I get what you mean, not being able to capture the design intention of the designer in some sort of common file format is a bit of an oversight. And I don't think that it's anything that's likely to get fixed at all ever. Now, I'm not even anytime soon kind of thing. What's the incentive for the different manufacturers to settle on a standard? I don't see it. I wouldn't hold my breath.
Yeah, I think there's none. And I think I do kind of agree with the folks who say, well, STEP is imperfect, but it's the best we got. But you can't do exactly what you want to do. You can't go back through the history there. You can't, it's not as easy to say, if you had the fully parametric design and you had a different bearing, just because you weren't able to buy the exact one Colin used in his design, you just put in the specs for that bearing and hit go and you'd get the right thing. And here you have to think a little bit harder, right? You have to scale everything up to make it work and whatever. Is that really hard? I don't think it is. And you can still take most of the advantage of having the files. Having the files is a huge step ahead from not having anything. But it's not quite perfect yet. I think it'd be a neat thing to have a CAD file format that was both open and fully parametric, maybe with a history like you suggest. All the different CAD programs out there have theirs, but that doesn't mean they're interoperable.
As for the knob itself, I love the fact that the design, I love the lack of wobble, the thought put into that, the big bearing and the precision of the encoder, but I really think this thing needs to be in anodized aluminum. 3D printing is great, but machine this thing out of aluminum, anodize it, yeah, that's what I'm talking about.
Funny you mentioned that. Someone said that in the comments, and Colin himself comes in and says, oh yeah, that's in the works. So great minds think alike.
A wonderful piece of desk art, if nothing else, but then something that actually feels, wonderful to use. And I forget which one it is. Sensual, sensuous. I don't know. That sensory sort of thing that you get when you're operating something like that. It kind of reminds me of the knobs on video editing suites back when I worked in video in the 80s and 90s. It was, you felt like you were manipulating something and you you were able to get just a tiny little bit of motion off of it because it was so bulky and massive. They're great artifacts, and kind of miss things like that.
Everybody needs one, I swear. A bunch of people also say this one needs something like those old jog wheels have. Like a lot of the old ones have like a dimple to put your finger in, so you can put your finger in there and do this like rapid spinner movement. And that's kind of fun. This one's on the side of your desk, so you could kind of just like spin the side of it, I imagine. There's tons of room for modifying this, and I think that's part of what half of the people who are talking about the step file, the open source 3D printer files are talking about, is that these are people who want to put a dimple on it. And I appreciate that too. So I want to see more of them. So make your own, send it on over to us. We'll put together a gallery of Ploopy peripherals.
The Ploopiest knobs. Before I get started on my first one, I apologize for the world's loudest lawnmower. Holy every time he fires that thing up, and of course it has to be on Wednesday this week. I don't know what this thing is powered by. I don't know if it's got like a short block Chevy in it or something. The good thing is it's so powerful it only takes a few minutes to cut the lawn, so it should be over soon. I apologize. At least the lawnmower is drowning out the dogs barking next door. And first up for me is standing desk. Uses pneumatics to do the job. This is Matthias Wandel. Everybody knows Matthias. He does the wood gears, and he makes wood do things that wood shouldn't do. In his shop, he builds machine tools out of wood. He builds the gears out of wood, rack and pinions, all kinds of cool stuff. He's staying away from wood for this one because he also has an endearing love of standing desks, and specifically the adjustable kind. And he's done a bunch of videos about the different standing desks that he's experimented with. And generally, he's using like a commercially available lift mechanism and putting his own top on it and then customizing drawers and stuff because Matthias. Most of the stands, the frames that he uses all have a common mechanism. You know, it's pretty obvious. You would use a linear actuator of some sort, and, you know, what's like a screw drive kind of thing, and you jack up the desk to, you know, from sitting to standing height. Easy peasy, shouldn't be, you know, there's not too many surprises, but he still manages to find some interesting facts out about these electromechanical ones. This one, however, is from Cloud, and, you know, full disclosure, this is a sponsored video. They sent him this stuff. But when he does a sponsored video, you kind of don't know what's going to happen because he's going to be brutally honest about what the pros and cons of this, whatever it is he's reviewing, are. In this case, the Cloud standing desk is not electrically operated. It's pneumatically operated. So it's got the gas struts, the gas springs that are similar to the ones that, you know, hold your hatchback up, hopefully. I've got a couple that are kind of sagging, and when they get a little cold, bam, and smack you in the back of the head. Exactly. That's kind of almost a concern with this one that people had in the comments. Well, is this just going to, you know, like your pneumatic adjustable chair, and that all of a sudden you get that sinking feeling and you find out that you're, you know, 2 inches shorter by the end of the day because the cylinder's been leaking? I mean, yeah, I guess that's possible with this system, but it's not just a adjustable pneumatic cylinder desk as in, you know, the way you adjust your chair with just, you know, pulling a lever and then sitting up, you're taking the weight off of it, and the chair comes up and now you're at a new height. That really wouldn't work for a desk because it's, you know, the load on the desk is variable, depends on, you know, how many monitors you want to put on your standing desk or what you're using it for. But also you've got two legs that you kind of need to keep in sync. So he tears into this lift mechanism, finds all the goodies about it, all the details. He looks at how the sync mechanism works, which basically ends up being these metal tapes that stretch from upright to upright through the stretcher in the middle, and finds out how they work. The struts themselves are in the uprights, and there's a whole bunch of stuff that he found out about them, including interesting things like how you get a 3-piece extension tube to properly keep itself centered. And there's some great stuff in there. But the other thing is that this thing has a gas cylinder on it. That's the sort of the reservoir for the pressure that you need to operate these pneumatic actuators, and that actually is charged up by cranking. So you put a lever on, or a socket wrench or something like that on a fitting, and just crank this thing up to the correct level, and that pressurizes this reservoir, and then that provides the pneumatic power to operate the cylinders. It seems like it's a really good design. It seems like it can hold an awful lot of weight. He puts his mini lathe on there, and it's not a very heavy lathe, but it's heavier than what most people would probably put on a standing desk. Puts his kid on there, and I half expected to see him shoot through the ceiling and have his legs just dangling in the shop, but he did fine. His kids make good ballast for projects like that. Matthias doesn't really hit you over the head with a sales pitch, and he does call out what's wrong with it and what's right with it. So very honest about that. But the really cool thing is the mechanisms in there and watching him take it apart and learning how it works. Always enjoy a good Matthias video.
Yeah, if you can hold your nose for the kind of advertising sponsored stuff, he does a really good job with it. And like you said, he tears it apart, and he does not hold his punches either. Like when he's doing it with his kid, he's trying to calibrate that pressure thing, and he ends up way over cranking it because the thing has a bunch of stiction and he can't get it to lift his son up. And then he starts lifting him and his son just like shoots up, and he's like, well, I guess I went too far, and he backs off that. And then he points out that it's got a different stuck and moving friction, and that just changes the design, and he gets to talk about that. And then there's a bit where he's pushing down on it with the lathe, and he notices that at the end of its travel it runs out of pressure because, well, the air is all expanded out and it just doesn't have as much pressure anymore. It's like a spring, right? And so he's like, well, that's kind of a limitation of this. And then he's pushing it down, and he notices that it pushes down easily if you push it down slowly, but if you push it down hard, the volume of air that has to move through these tiny orifices is too large, and it kind of sticks. And he's like, well, I guess that's a safety feature. I'm like, yeah, thanks. But like I said, it's a legit review, and it doesn't seem to, he's not like pulling punches like some of those people. And it does look like it's a good standing desk. I have the IKEA one, and I should have known better. It's got two legs, and there's no way to make something not wobbly that's on two legs except to make it just incredibly beefy. Really, things that don't wobble have 3 legs or 4 legs. Things that have 2 legs always wobble back and forth, and this desk is a horrible, horrible example of that. And I actually fix it by, this is so janky, I have a 2x4 with a couple cutouts on it that I use to lock with the edge of the desk at a couple different heights that I use all the time. So when I'm soldering on it, I can actually lean on this desk, but only by virtue of the fact that I have a 2x4 cut to exactly the right length to make the third leg for this godforsaken thing. So I'm a cheap bastard, and I'm paying the price is what I am. But I'm a cheap bastard with a calibrated 2x4. Well, my next hack is actually an OC piece. It's a long form in disguise, but I had to throw it in here because it is so useful. Data visualization and aggregation, time series databases, Grafana, and more by Maya Posh is kind of a rundown of a bunch of different options you have if you want to log data that happens over time. And she mentions a bunch of different databases here. A lot of them you've probably heard of. I think Influx is one that a lot of hacker type projects have deployed. I really like RRD tool. She mentions that one as well, which is awesome. It's a ring buffer, basically. Like it stores your data, but it overwrites old data, and you can tell it how much history you want. I like that because I really don't care about what happened 2 days ago for the stuff I'm doing. I really just care about, figuring out, what screwed up an hour ago. If that's your case, it's an awesome type of database because it automatically kind of overwrites the old data. And so you don't get what Maya describes as the data hoarding problem, where, if your time series just keeps on going forever, then you have like 12 years worth of data. Of course, you can snapshot with RRD tool. You can, before you throw away yesterday's data, you can maybe make summary statistics about it. Like what was the maximum, what was the minimum, and then store that. So you can kind of do your data reduction on the fly and then use RRD tool itself to do the data logging. Super cool. Of course, you want to make pretty graphs about this, and I was looking forward to seeing what she came up with, and she actually doesn't come up with anything better than Grafana, which is the kind of standard time series-y, dashboard-y tool that you've probably seen people use before. And when it does what you want, it is hella pretty and, easy to configure. You press the button that makes it do the graph you want and you get the graph you want. And that's awesome if you have any of the standard use cases. If you want something custom, you end up really banging your head with Grafana. And that, I don't know what to say. That's the way it is. I'm surprised she didn't come up with hacker alternatives for that. And honestly, I don't like the install for Grafana very much. It's one of these newfangled kids these days with their installers, and it's just a pain in the butt to install. Again, it's a pain in the butt you only have to go through once, and it works just fine on a Raspberry Pi. And in fact, we had a post a few years back by Inderpreet Singh where he wrote up how to install Influx and Grafana in a Docker environment on a Raspberry Pi. And that's actually probably the simplest way to do it, because you just fire up the Pi, install Docker on it, and then just download somebody else's pre-done configuration and you're off to the races. So that's pretty good. In the comments, people mentioned Victoria metrics, which I've never seen before. And honestly, for my purposes, that looks like the next one I'm going to look at. It is a lot smaller. It's a precompiled binary. It's not a big system hog. It seems very flexible. It's also completely open source. Looks really good. El Gru writes in saying +1 for Victoria metrics. I can run it on a Raspberry Pi Generation 1, and it works better than the others on Gen 3 or Gen 4s. So it's just a super small, tight, optimized time series database engine. And I think that's awesome because, when I do a data logging project, I usually just throw the timestamp and the data into a big CSV file and call it good. And then I write my own code to plot the data or whatever else, right? But then doing that live is kind of annoying, and I have this Python routine that I'll use, and it goes through a loop, but it refreshes every second, and it's super not efficient in terms of, processing power, but I don't care. But it works, but it's so janky, and it's not very pretty, and I really need to come up with a better general purpose solution. So I was really stoked that Maya wrote this. Am I going to have to bite the Grafana bullet? I might. But it strikes me there's a whole bunch of hacker projects where, you want to monitor one or two things to see how the system's doing. If it's a robot, maybe you want real-time telemetry from a couple things and battery voltage and, maybe how much current it's giving to the motors. This is all like super useful information to have in one picture, in one of these like time series dashboard-y type things. And it seems like it's a shame to me that we don't have a really simple solution for this sort of stuff just out of the box. It still all feels like it's overkill for me. It feels like some of this, this stuff is designed for like monitoring the health of large data centers. And I really just want the little robot toy I have running around my living room. The temperature of my coffee roaster.
Looking at the quality of these graphs just kind of takes me back a little bit. I mean, I spent most of my career doing scientific programming, and if you're doing scientific programming, you're going to have to graph something. Somebody wants a graph every time. And guaranteed, if they, whatever package you have for doing the graph does not support the kind of graphs they want. That's what scientists do. They invent new ways of looking at data. And having a package like this probably would have opened up a lot of... I always managed to deliver, but at what cost, right?
Right? Yeah.
Being able to deliver with a library of much, much better looking graphs probably would have been really nice. A lot of stuff that I had to do by hand would have been a lot simpler with something like this. So that's in the past.
Getting the proper visualization of your data is super, super, super important. And if anyone has any other good solutions, head on over either to Maya's article or the comments here for the podcast and let us know. Because I'm like 90% happy with Grafana, but only 90%. I want to be happier.
It's always that last 10%.
Make it simpler and more flexible. And play the tuba underwater.
Alrighty, next up for me, a scanner for Arduino-powered book archiving. I love me a contraption, and this is a contraption, and I don't mean that in a popsicle stick and thumbtack sort of way. This has a lot of polish, this book scanner. However, it's got a lot of axes. There's a lot going on in this project. Basically what this is the kind of machine that you would use to capture a book, digitize a book. And there are a lot of different ways to do that. You could just sit there with your camera, click, 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 with your phone, spread out the pages, but you're going to get bored of that pretty quickly, and there's no automation that's really possible with that. There are professional book scanners that I've seen which use two cameras that face at an angle to each other. So one takes a picture of the page on the left, and one takes a picture of the page on the right. This isn't quite as complicated as that, although it does have a lot of elaborations. Really, the best way to see what this is all about is to click through to the original Reddit post, and I think it was our Arduino that demonstrates how this works. This one also automates the handling of the books themselves, as in take them off a stack, feed it onto a conveyor, and then have the book automatically scanned. To do that, it uses a whole bunch of servo-operated arms and other levers and devices to hold down the book physically on the bed of the scanner, to flip the pages from one to another. A piece of glass then flips down to kind of squeeze everything flat for the overhead camera till it gets to the end of the book. There's some really neat ideas in here. The one that really stands out to me is when you're handling paper, you often need suction. Commercial paper handling machines almost always have, some sort of vacuum generator, either like a Venturi that uses, use compressed air to go past a Venturi to create suction, or like a legit vacuum pump or something like that. This is by Brad Matson, and he comes up with a wonderfully clever way to handle the vacuum problem. He just uses a fan. It's a regular little box fan, a little ventilation fan that you would use to cool a project. But he just puts the intake side down toward the paper, and it sucks the paper up gently enough to handle it, and then the arm moves the paper over, turn the fan off, vacuums off. Genius. Absolute genius. Why would I not think of that? He thought of it. Why didn't I think of that? I don't know. But ton of different details. The book has to be precisely positioned so that it can, the camera has a view of both pages. He wants to take pictures of both sides at the same time. There's a whole routine at the end for closing the book up and looking at the back cover, taking a picture of the back cover, and then ejecting this off the book off the conveyor so they can get the next one. A whole bunch of stuff going on the laptop that's connected to this, including scripts to assemble the scanned images into some sort of sensible order, scripts to detect whether you're looking at if you keep looking at the same pages over and over again, that would obviously mean the page turning mechanism isn't working as well as it should, and it can correct for that. All kinds of wonderful little automation tweaks and hacks in here that are delightful.
This one's phenomenal. It's also definitely like the Rube-Goldberg machine of book scanners. Yeah. It rolls it into place. It takes the front and the back cover, like you said. It flips it over. It's really, really sweet. We've seen a lot of book scanners on Hackaday, and I was actually looking back trying to dig some up. There's a nice page-turning book scanner roundup from 2011. Half of those links are dead now, unfortunately, which, curse you, decaying internet. You'll still find some good inspiration there if you're into this. And then more, quote, recently, in 2016, Jenny List covered an automatic book scanner to bring knowledge to Ethiopian students. This one is really sweet. It's kind of the polar opposite of the one we're talking about here, in that it's almost entirely hand operated, but it's got a super clever page turning mechanism where it just kind of falls down a triangular slit and then gets pushed up the other side as you run the book back and forth across these tracks. So you run it one way, it's on a V, and it takes two cameras, take pictures of the two pages simultaneously, again, pressed up against glass. Here, just by gravity, book holds itself down against the glass. And then you slide it over the other way, and it flips to the next page, and then you slide it back, and it takes another picture. And so it's actually a really quick operation. It requires someone to sit there and go zap, zap, zap. But it looks like it's a heck of a lot simpler solution to a similar problem. And so if, you've got someone there, a grad student or something, to go run the pages back and forth, their time is free. So it's easy. This was a Hackaday Prize 2016 entry. Man, Hackaday Prize. Blast from the past. But really cool project for that one, and a kind of a more standard design, with the exception that it's been stripped all the way down and relies on some human power. But I think there's some room on the spectrum between this kind of fully manual machine and then this, and whatever you think is right for your book scanner. We've probably covered a project like it on Hackaday.
Rube-Goldberg, with the highest respect for Mr. Goldberg, of course, because he came up with some pretty clever things. And saying that, I don't think is necessarily a pejorative here.
This project does lean a little bit into automation for automation's sake, and again, I'm totally down for that. But like, if you wanted to, scan a bookshelf of your books all into PDF and then get rid of them to save space or something, A, you're a horrible monster because actual books are better than a PDF. But B, I hear where you're coming from, and this might be the device for you. Well, bringing up the rear for me, a duo of posts that are projects from the Cornell University ECE 4760 class. This is a microcontrollers class. It ends with a final project, and they have to A, document it fully, B, make a video about it, and C, for more than a decade, they have submitted their projects to Hackaday. Thanks very much, ECE 4760. These two are awesome. Oh, the microcontroller this year is the Raspberry Pi 2040 Pico, and I think some of these are using the Pico and some are using the Pico W, the wireless Wi-Fi enabled version, but who cares? Small, cheap microcontroller. How much can you do with it? And that's what I liked about both of these two projects, is they really push it, actually. The first one by Sam Ezra and Ari is audio localization gear built on the cheap. This is a 3 microphone array. They have 3 little MEMS microphones that sample at 50 kilohertz. They throw the data as fast as it's coming into the Pi Pico and do phase shift and correlation analysis on the data coming in to figure out where the sound is coming from. And it's a really cool project. Their demo works absolutely beautifully. Like, it's really cool. They have a radio playing, forgotten what it is, some cheesy 80s song, and they're moving it around, and their visualization tracks it almost perfectly. Like, it's really cool. But they do a few clever things to get around the RP2040's small amount of memory and, not quite all the way up to snuff processing power. And that, I think, is really cool about it. It's a neat DSP project, and I love neat DSP projects, but it's also got some clever tricks to work on a limited resources system. So for instance, one thing they're doing is they're sampling into kind of a ring buffer. Doing the correlation analysis all the time is computationally intensive and probably too much for the little RP2040 to handle. So what they do is they look at a ring buffer and they say, oh, here we've got some sound that's actually loud enough to warrant looking at. Let's look at it. And then they take that chunk and then only then do the math on it. For the display of the graphics, instead of trying to figure out the lag between the 3 signals and then plot it, based on the mathematical distance there, they've actually pre-calculated all of the lags between the 3 microphones and mapped them out beforehand onto their 2D display. So it doesn't have to do that math in real time. It just kind of does it in a lookup. And so if the delay looks like this between the 3, they plot it on this pixel. And then they've got some time smoothing going on. Anyway, really, really clever project in a whole bunch of ways. Amazing they can get this done with, like 3 $1 MEMS microphones and a $6 dev board. Like, kudos. The other one is Anaya, Lawrence, and Shao's Cucumber the Robot Dog. This one uses the wireless version of the chip. It's got a web interface to control their robot dog. Robot dog itself has got a whole bunch of those cheap yellow gear motors moving its legs, and it's on wheels, and it's got a bunch of awesome poses, and it can bark and it can howl, which kind of sounds like it's mooing, but whatever. All 3D printed, sweet web interface. It's just a really nicely finished design and looks like a heck of a lot of fun. And that's probably also super cheap and super accessible. So, kudos to them.
So I guess ECE 4760 from Cornell is the gift that keeps on giving a Hackaday, right? Even after Bruce took off the Hawaiian shirts, or took off to Hawaii, I guess.
They're well documented. That's part of their grade, right? They're well documented. They're beautiful. They're clever. They're inspiring. I remember, maybe 15 years. I don't know how long we've been doing this.
Okay, my last pick is blowtorching electroplated 3D prints for a good reason. This is from Hendrik, and it's based on a video, a YouTube video. You should go watch it because it's a very cool process. I've seen electroplated 3D prints before and never been impressed with them. They look like you put layer of crappy graphite paint on a 3D print with and you can see the layer lines, you can see the graphite, and you can see the sort of crappy looking copper or nickel or whatever you plated it in. Not this. This is a completely different level of electroplating, and I would say almost qualifies as metal 3D printing, because at the end of the day, there's no plastic in these. It's just metal left over. The process is not simple, but not totally inaccessible. You would need to switch up your filament to PVB, polyvinyl butyrol, I guess, which is basically the sticky, tough plastic that goes between two layers of glass and a laminated windshield and keeps disasters from happening with windshields. It's a plastic that has the right characteristics, chief among them being you can smooth a PVB print with isopropyl alcohol. And Hendrik does that. He also does it in a resin printer and uses a special casting resin for that sort of UV cures to almost like a wax-like consistency. The point here is that these molds, these positives, I guess, would be melted out after electroplating. And both of these substances, both of these plastics are amenable to that. And then he used copper paint to make the plastic conductive. He applied this with an airbrush, and honestly, I thought that the print looked pretty good after the copper paint. He probably could have stopped there, and it would have been fine, but no, he wanted to actually make it into into a metal artifact. And once it was covered with this conductive metal paint, he goes through the whole electroplating process. He used copper, obviously, for the bust. He had another piece in there that he did in nickel, which I've always really, really liked the look of nickel-plated stuff. It's got a gorgeous look. The copper came out fantastic. And if I remember correctly, he did a couple of layers, like 3-4 layers of copper before he took the whole thing out and did a melt out with a butane torch. And basically just melted the plastic all the way out. It did oxidize and change the color of the copper that was left over, but the shell of copper was self-supporting, strong, even thickness all across it, and polished up decently. Cleaned it up, put it in for another bath in the electroplating to cover up that last sort of discolored, oxidized layer. And the results are just fantastic. This thing looks just beautiful, shiny copper. Everything about it was perfect. No layer lines, no paint artifacts. Same with the ones that came from the resin print. Those looked fantastic. The nickel-plated one was great too. All of it was... It didn't look like any of the electroplated 3D print projects I've seen before. Absolutely everything about this was gorgeous, and I'm kind of keen to try this. And like I said, it's almost an additive metal printing. You're not printing the metal directly, obviously. You're printing the print, and then you're covering that with metal, but that's still an additive process, so I kind of count it as metal 3D printing. Flame away in the comments, if you will.
Is electroplating additive metal?
Additive manufacturing, right?
It certainly is additive manufacturing at the atomic level. So
yeah,
right. Longtime podcast listeners will recognize the name Hendrik. Every time he does a project, Christina Panos picks it up because his techniques are just getting better and better and better and more refined, and this is just outstanding. He's laser focused on this metal plating 3D printing thing, and it just absolutely shows. Watch his old videos if you want to get started with this stuff, and you'll see, the basics and kind of all of the gotchas, where not to put your fingerprints and, what chemicals work with what and the whatever it is, the electrical affinity table and, which metals you can plate on top of which, et cetera, et cetera, et cetera. It's absolutely worth a look. Like poor Dan here, it will make you want to metal plate things just for the sake of metal plating them, like, for no better reason than they look hella shiny. And yeah, fine, sold.
I'm not ashamed to admit I like shiny things, especially shiny copper.
And as an old ABS printer, I used to do the acetone smoothing thing. It's really twitchy, too much and you start melting people's faces, and too little and you still have the layer lines. It's a real trade-off. And plus acetone acetone vapor is not the worst thing in the world, but don't smoke around it. And getting it to stay a uniform fog is actually harder than you think. Acetone fog kind of settles out, and so you get a gradient in your big Tupperware that you're doing this in my experience. It's harder than you think. So this isopropyl with kind of a vaporizer looks really good to me. I'll have to look into PVB for that kind of application. Or just embrace the layer lines. But it doesn't work with this like super shiny, super smooth aesthetic that Hendrix got going on here. And I get that. No layer lines. All right. My first quick hack, turbine blower 3D prints every part, including triple planetary gears by Tomek. I mean, do you need a hand-cranked planetary gear fan? Probably not. Do you absolutely need one that prints in place? Probably also not. But I think it's a great demonstration of how far our print-in-place 3D planning has become. It used to be cool just to get like a print-in-place hinge working, and this is so much more. So give the project a look if you want to kind of see where the state-of-the-art here is. You'll get some good ideas. Merabyte Windows 95 on PlayStation 2 works as well as you expected. That is kind of a biting title, but I love it. The project is also a reminder that you can do anything with emulation. It just might not happen as quickly as you want. The PlayStation 2 is lacking like all of the opcodes that Windows 95 needs, but you can emulate it, right? Once you've got a computer, you can write a computer to do anything, and that's what's going on here. Really cool project. Last up, Zeal, phone keyboard reverse engineered. This is a neat old Alcatel keyboard. I don't know if you'll ever find one of these, but it speaks serial and kind of dumps it out. This is the usual figure out where the voltages go, figure out what the protocol is, make a little level converter, plug it into a logic analyzer, and figure out how it's talking. But it's kind of the basics of low-level hardware hacking that we all kind of go through, and Al finishes up this write-up with, truthfully, there isn't much chance you're going to find this exact keyboard. However, the process of opening up a strange device and reverse engineering what it is all about is absolutely classic. And that's true here.
Alrighty, my first quick hack is Pi Network's The Smith Chart Way. If you've ever been confused by Smith charts, you're not alone. These semi-fractal round charts that have reactive side and an inductive side and a real side and an imaginary side. And if you're confused by them, that's okay. Ralph has got you covered. He's looking at source and load impedance calculations using a Pi network, and the Smith chart walks you through which lines mean what, which arrows go which direction, and what it all boils down to. Next up, are service loops a good idea? This is a scale of service loops that I was not previously aware of. Normally when I think of a service loop, I think of maybe you're bringing a cable into a house and you want to put a little extra on there in case somebody needs to make an adjustment, and plus to maybe drip some rain off of the inlet. This, however, is much, much smaller scale. Looks like a mil-spec kind of connector. This is by High Performance Academy, and they're showing how to make the loops actually in the wires right behind the pin in the connector. Is it a good idea? Is it not? That's sort of the open question. Is it going to cause extra inductance inside the shell of this connector? Possibly. Is that a problem? Maybe, maybe not. But there's probably good reasons you want to include a little extra length of wire in case that pin needs to be repositioned in the shell of the connector. And finally, Move Over Cybertruck series hybrids from Edison are on the way. Edison Motors is a new startup out of Canada that's trying to do electric trucks in a completely different way than anybody else. Got an interesting backstory. They're basically trying to construct a company town now so they can build enough electric trucks to make a difference. There's a whole interesting bit about that, but the thing that I find most interesting about Edison is that they have a very distinctive blue color for their trucks. And the backstory on that is kind of interesting. They chose their blue color based on the hex triplet 042069. 42069. Nice. So anyways, that comes out to a blue color, which is actually a really nice color, and that's kind of their brand now. So go check them out. It's pretty cool.
All right, now it's time for our Can't Miss articles. These are long-form pieces written by our fantastic Haggaday writing staff. And the one I picked this week is the most controversial, the craziest of the week. Lewin Day wrote up, one laptop manufacturer had to stop Janet Jackson crashing laptops. And this is sparked off by an article by Microsoft engineer Raymond Chen. During the Windows XP era, one manufacturer of laptops had trouble that when people played certain MP3 files on it, the hard drives would error out. It looks like what was going on was that there was some resonance inside the laptop's case that was vibrating the hard drive at exactly the right frequency to make the head skip a little bit as it was spinning around. And it would get bad reads, and every once in a while this would crash the laptop. You know, Janet Jackson's Rhythm Nation is picked out here and inspired Joe to do some fantastic art, by the way.
Again, yep.
I sit around, and now I have this as my earworm for like the past day because I was editing this piece. Thanks a lot, everybody. But it wasn't just Rhythm Nation. In fact, it was any track that had this particular kind of bass frequency in it. And the solution, and this is so janky, was to just notch filter out that frequency. And so like any song that had whatever they say it was like 80 something hertz, 84.2 hertz / 87.5. He found that it reported the drive to have its largest vibrational peak at around 87.5 hertz. Anyway, something in the 80 hertz zone was causing the hard drive to wig out. And the solution was just to notch the frequency out, which meant your music didn't sound right, but at least it didn't crash your hard drive. So I guess that's good. This is just one of those like horrible, dirty secret hacks that went on back in the day. And I've talked to some people who worked at Microsoft, and back when Microsoft used to be super crashy and before Windows NT, actually, Microsoft used to be kind of patched together, and everybody would come to them with requests to fix this specific thing or fix that specific thing. You know, this hardware manufacturer would say, hey, we need you to do this for this driver and that for that driver. And hey, can you help us with this? This would make it better. And of course, Microsoft is like, yeah, we'll do it for you. Yeah, we'll do it for you. And they end up with, you know, patches and patches and janky stuff piled up in this like huge pile of cruft. And so it doesn't surprise me at all that some company would notch out a particular frequency to keep their hard drives from crashing out rather than just like do the reasonable thing and engineer it better. But whatever. Anyway, love it. And it reminded me of shouting in the data center. I'll throw that link in the notes for you. You should go check it out. This is where Brendan Gregg is working at Sun and discovers that some of their hard drives will start getting huge error rates. And it was because there was some noise, because a screw came loose, for instance, and a hard drive was vibrating, and it would vibrate at the right frequency to like drive all the other hard drives around it crazy. And he demonstrated this effect by going over this huge rack of hard drives and just yelling at them. And then he pans over to the screen and you see the error rate spike. And it's absolutely fantastic. And so all you people who doubt that this is a real effect in the comments, go watch Shouting in the Data Center. This is the real deal. And it's been known for a long time. And, you know, think about it. You've got something spinning at 5,400 RPM or whatever back in the day. if you hit it with just a little bit of energy every time it goes around that cycle, or some even number of times every time it goes around that cycle, you're going to bounce things around in there. It's, it's just physics. And old spinning rust hard drives have a lightly sprung read head on them, and it's just physics.
If you've been inside a hard drive, you can see exactly what's happening. That head is just, angled out there on a very thin piece of metal that definitely has a spring constant. You can see where all of this is coming from. And I remember many, many years ago, the analogy of what's happening at the surface of the platter is like a jetliner flying 3 feet off the ground, full speed 3 feet off the ground. Yeah, it can do it, but the margin for error is practically nothing. So a little bit bounce up and down, anything at all, you've got a problem. So I could see that. Now, where people seem to have a problem with this was believing that a laptop speaker could reproduce a 82 or 84, 87 hertz note. And I don't know about that. I mean, the low end on a laptop is probably not great sound-wise.
Yeah.
But does that necessarily matter just because you can't hear it? Just because it can't reproduce the sound? Does that not mean, or does that mean that the vibration isn't happening? Like, is the speaker coil moving back and forth and causing a physical problem, but maybe the speaker cone isn't coupling that to the air? You know what I mean? Is it causing a vibration that's getting transmitted through the case of the laptop? Now they say that this didn't happen in any PCs, desktop PCs.
Yep.
Something curious about the internal anatomy of a laptop maybe makes it more likely to happen there.
Laptop drives were new back then. They're super miniaturized. They're probably a lot lighter. Like the components are probably lighter and more subject to vibration. The thin metal case is probably a larger membrane relative to the size of things you have to move around, relative to the inertia of the tracking heads. I totally buy it. And 80 hertz isn't that low either. I mean, it's laptop speakers probably don't do it. But this effect was supposedly, at least, reported with 2 laptops of the same brand, where one of them is playing the song and the other one was nearby and crashed. So I have no idea what kind of speakers these things had on them. Maybe that's the missing link here, is that somebody designed a speaker with one of those like Bose acoustic chambers that gives you a high resonant peak at exactly the wrong frequency or something. I mean, maybe.
Could be, yeah.
All I know is it does make me want to test it out. Does make me want to shout at my hard drives. Although my guess is that technological progress since then has probably pushed this problem out of the mainstream. I just love the janky ass solution. Oh, we hate it when the hard drive gets 82 hertz. Well, just don't play 82 hertz. Maybe someone in the comments, maybe it was Raymond Chen, pointed out, well, at least it's a better solution than having it just not play Rhythm Nation. Like you could imagine the report came in that, Rhythm Nation was causing it to crash. And so they would just blacklist that song. So, then of course they discover that every other song has the same frequencies in it, and, something else would crash it. So notching it out is, I guess, slightly less janky, but
a little thought put into it. Okay, my pick this week for Can't Miss article is from Maya Posh, and it's the 2025 Iberian Peninsula blackout, from solar wobbles to cascade failures. And this is also one of those unintended consequence things. If you'll recall, last April, the entire Iberian Peninsula, so Spain and Portugal, suddenly was plunged into darkness. All the electrical grids collapsed, and it lasted for, I believe, the better part of a day or more than a day. Big event. Certainly caught the attention of the news media around the world, but it also caught the attention of regulators, engineers who are interested in how electrical grids work, and pretty soon everybody was coming up with theories on exactly what happened. I remember at the time that there were news stories that said Spanish authorities, or the power grid authorities in Spain, had made some sort of statements that it was, like Maya mentioned in the title, solar wobbles. And I didn't really know what that meant at the time. I assumed it had something to do with the solar cycle, and there was a solar storm, and it somehow knocked out part of the grid in the Iberian Peninsula. Turns out that's not exactly what's had to do with. It seems to have more to do with the makeup of the generation methods in the grid at the time, which had gone to, I think it was like 60% powered by wind and solar at the time that this happened. This kind of boils down to the lack of inertia on a inverter-based grid. So to, put that into perspective, I mean, like, you've got a traditional generating plant like a coal-fired or nuclear or hydroelectric, whatever. All of these have large spinning masses, right? Because you've got to turn a turbine, and the turbine's going to turn a generator. Whatever it is, something big and spinny has to be in the line between the fuel, the burning of the fuel, and the generator that actually is going to turn the coils that make the electricity. So, and those things, have an awful lot of inertia, especially when they get spinning up. That inertia tends to mask a lot of inconsistencies in the frequency of power generation, and that is almost more than anything else about power generation. The frequency is kind of the critical factor. I mean, it was only in April. It's not that long ago in the grand scheme of things, and engineering reviews and after action sort of post-mortem things take a long time to fully digest. So when that final report comes out, things may appear different, but for now it certainly looks like the lower amount of inertia is possibly what was the root cause here. It's a little ironic that something like a wind turbine kind of doesn't have the inertia that I mean, still, it's a big spinny thing, but it doesn't really have the inertia because you don't know when the wind is going to be blowing. It may not be blowing exactly when you need it to. And if I'm not mistaken, the generators that are inside the nacelles up on top, those are DC generators, and they use grid following inverters to change it to AC and get it out on the line. Paging Brian Cockfield, I think he would know the answer to that. It's a little weird that a big spinny thing like a wind turbine is considered a low inertia sort of power source. Is there something that we can do with solar? I think solar is kind of more of the problem in this case, the solar plants. Is there something you could do to put inertia back in? It seems to me like, I mean, the naive answer would be, yeah, sure, increase the inertia on the grid and prevent things like this from happening again, or at least make them less likely.
This event just happened a month ago. It was like the largest blackout in European history ever. So, no small potatoes here. It's really weird. Nobody, and this report doesn't either, nobody really knows what the root cause was. Something happened to make fluctuations in the system, but like you said, the photovoltaic plants were most of them running in grid following mode. The way the grid works really quickly, and the way it used to be self-regulating because it had these big generators on them, and everybody agreed they'd try to run their generator at the same frequency. And so if more load is pulled out of the system, that kind of puts more load on the generators, and it makes them slow down. And so then you throw more coal on the fire, and the thing starts to spin back up again to, counteract the increased load. So holding the frequency constant was kind of this weird proxy goal that would balance the amount of power pulled out, which would want to slow the generator down, with how much you're firing it, which would make it speed back up. And this loop was always kind of slow. And but even still, back in the 20s and 30s, if you had a new big use of power in an area that was geographically separated from where it was produced, you could have these weird coupling effects between a power plant over here responding faster than a power plant over here would respond, just simply because there was a lot more wire in between the two of them. And so this has always been a problem, actually. And even generator power plants have some sort of extra inertia built into them in the form of kind of giant capacitor banks, basically. And why the new solar stuff didn't is unclear in about 2020, so about 5 years ago, they started requiring new photovoltaic plants of a certain size to also be grid forming, just like you would with a coal or gas fired power plant. And so the problem here, I think, is that they've got a lot of pre-2020 solar and a lot of small generation that doesn't have to do grid forming as well. And on this particular nasty sunny day, right? They were at something like 60% of their energy generation was solar, and probably some large fraction of those megawatts weren't grid forming. And so they were grid following. And so what happens is, they just produce more and then they produce less, and then they produce more and then they produce less. And you get these horrible oscillations that when they get out of bounds, start to trip safeties. And so you get these growing oscillations. It's like shouting at a hard drive, actually.
Yeah.
when the frequency is just right and you have a mechanism in there that amplifies it, they would grow out of control. And so the solution is, I think, as easy as it is painful, which is just these photovoltaic systems have to be built with some grid forming capability. And that's just the way it is. I know Lewin wrote an article about this also happening in Australia. I think Sydney has this problem right now where they've had grid instabilities because of solar. There was a US blackout in 96 or something because a lot of newer traditional conventional power plants were faster reacting. The unfortunate consequence of this was that they were grid destabilizing. And so post that blackout, we had new regulation in the States to kind of smooth those things out. What's interesting about that, and I think this is the real future. So I think the immediate future is that PV things need to be built with enough smoothing capacity that they can not contribute to the problem at the very least. But a really neat new development, and this is hinted at in the very end of the Red Electrica paper she cites here, are wide area monitoring systems. These are WAMs and PMUs, phasor measurement units. And what the goal of both of these is to stop using the frequency on the line as the only thing that tells generators to generate more or generate less. And what they're doing is they're building an out-of-band signaling system, basically. This is the wide area monitoring system to say, hey, don't follow the frequency at all because this is causing, voltage and frequency spikes. Instead, we're going to have a computer system that says, hey, generate more, hey, generate less, by watching carefully all the local demand and matching it that way. And so if they can do that, of course, that kills the instability like straight away. That solves the problem because you have kind of a centralized network figuring out how to do the smoothing and how if everybody can just contribute the power that is needed without over and under reacting, then problem solved. And so that's, I think, an interesting long-term development. These systems aren't widely rolled out yet. So, if you're looking to build a few megawatt solar installation in the near future, you're still going to be required to do grid forming. But in the long run future, I think the solar can get even cheaper if they can run this data network out that does this kind of out-of-band signaling. So I think WAMs is the 10 years out solution that will make solar super damn cheap. Whereas now it's just cheap. It's going to be absurdly cheap if they don't have to have the grid forming burden as well. So I think that's interesting, and that's a thing to watch. But right now, countries like Spain and Portugal are kind of playing catch up. They've got a lot of solar power, but a lot of it is this volatile solar power. And how they're going to manage that in the near term is certainly tricky. And that's kind of how Maya's article ends, is this is going to take a lot of large infrastructure rollout to solve this problem. And the sun ain't going to stop shining. So expect more blackouts in the near future because of it.
The grid following just seems like a recipe for positive feedback.
It is.
Destructive tendencies.
But it's such an awesome, it arose as a side effect of physics, right? And it solved the centralization problem when back in the day, the centralization and information distribution problem was hard, right? So you had the power lines carrying this frequency, and that was the information.
Right.
But nowadays, I think, none of us watch broadcast TV anymore. I don't think we're at a loss for getting, gigabytes of information in. And so I don't think that's a problem anymore. And I think what you were about to say, maybe it's time to get rid of that old system. Well, that wraps it up for this week's Hackaday podcast. Thank you very much for listening. And as always, if you see anything cool or do anything cool, shoot us a line, tips@hackaday.com, and you will find all of our fantastic links over at hackaday.com/podcast. And until next week,
Keep on hacking.
the Ploopiest knobs. We're done.
Scanner for Arduino. Oh, here comes the helicopter now. Jeez. Oh my god, I moved to the country so it would be quiet. Anyways, what is it?
Train is rolling. We are part of the Rhythm Nation.
Because that doesn't sound remotely familiar.
Yeah, well, I'm not Janet Jackson.
Thanks for clarifying.
That's it. That's the end of that one.
Yeah.